Hey class, this is Mr. Lee, and I am going over the ecological simulation homework. This homework will help you understand how different consumers help keep a ecosystem in balance. So for lesson 1, producers step 1, you're filling in this data table using the simulation. So for the starting population are recorded here for each type of organism, and plants always start at 5,000, so you can copy and paste that into these four boxes. And first, you are predicting whether these plants A and plant B will increase, decrease, or stay the same in population numbers. So plant A is a grass and plant B is shrub. So for example, I would predict that both plants would increase because there are no animals that eat the plants. So you're going to the simulation and you're turning on plant A, which is grass, and turning on plant B, which is shrub. And you'll notice that they'll populate the terrain here, and they'll also show up on your graph here. After you turn on those two buttons, they'll change to a different color. You'll click the run button, and you'll notice that as time goes on, one plant disappears and one plant keeps growing. So plant A, which is grass, went from 5,000 up to 10,000. And plant B, which is shrubs, went from 5,000 to 0. So in your data table, you'll record that 10,000 and 0. And then moving on to the questions, what kind of succession is this? I'm looking for the answer of either primary or secondary succession, and you're reading the scenario here, and you can look up primary or secondary succession yourself. For the second question, what assumptions does this model make about which organisms will survive, as well as the general terrain of this ecosystem? So looking at this simulation, obviously it's not real. The relationships between the organisms in this food web might not be realistic. Think about what organisms eat what organisms. In this terrain, when you add a plant or an herbivore or any organism, they are randomly dispersed into the terrain. Do you think this is always true? Are plants and animals totally randomized into ecosystem, or do they live in certain places? And then on this graph, for the first simulation, we saw that plants B, which are the shrubs, totally died out in 100 days. Do you think this is realistic? And do you think plants go totally extinct like that? Moving on to the third question. Do you find one producer to be dominant? Why might one producer be dominant over another? So obviously, using the data we just collected, one producer is more likely to survive or dominant over the other. And you're thinking about why might one producer be dominant over the other. So thinking about how fast the plants grow. Is one plant more likely to grow faster than the other? Maybe some of them are able to get nutrients better than the other. So make sure you write at least 2 sentences for this box. Moving on to the next part, you'll fill up a different data table. Again, filling in the starting populations, which is always 5,000 for plants, and for herbivore A, which is the rabbit, it's 1,000. Going back to the simulation, you can turn them all off and turn on plant A and plant B. If to connect an organism to a plant or another organism, you click on the herbivore and then it eats plant A. And so it'll randomly disperse the rabbits throughout the terrain, and you can click run to collect your data. Make sure that you predict what will happen to plant A, what will happen to plant B, and what will happen to the herbivore. Increase, decrease, or stay the same. Moving on to the question, does adding the herbivore establish a more equal field? Is one producer still dominant over the other? Why might one producer be dominant over another? So just answer this first part in one sentence. What happens when you add a rabbit? Does it make it easier for the other plant to survive? Is one producer still dominant over the other? Is one plant still greater in numbers than the other? Why might that be? Moving on to the next question. If the simulation included decomposers, how would your current results change? A reminder that decomposers are organisms that eat dead materials. So any organisms that die in this ecosystem would be broken down by decomposers and turned into soil for the plants to get nutrients from. So if this simulation included decomposers, how do you think this would change how plants grow, how plants survive, how different organisms in this ecosystem survive? Write at least one sentence. Moving on to number 6. How do producer population numbers with the presence of an herbivore compare to the primary colonizer model? So looking at your data table here and your first data table, what's different? How are the numbers between the plants different? And also, is one model with an herbivore more biodiverse or has more life than the other? And are they more likely to survive? Moving on to number 7, which is the last question for the homework. You're reading this explanation here, and you're answering this question from what you have learned from the reading above and your classmates' presentations about the biomes. How are humans contributing to the creation of a vastly rapid form succession? In other words, how are we speeding up the effects of the competitive exclusion principle and thereby altering the outcome of that ecosystem's natural succession? Obviously, when you put plants and animals in this ecosystem, they either survive or they don't survive. How do you think humans and their effects on ecosystems affect this survival rate? Right? At least one sentence. You are free to move on and do the rest of this worksheet, but I am only going to look for 1 through 7 on the homework. If you have any questions, please email me. Good luck.